Okay, we're going to do chemical mixture problems. This is our first shot at these. That's why it's chemical mixture problems type A. What we're going to do is we're going to mix two types of mixtures together and try to come up with a combined mixture. Chemical mixture problems, what it is two different substances are mixed together to get a desired result. Often one of the things is water and the other is something like alcohol, iodine, or antifreeze, or whatever else is mixed with water. So we're going to come up with, these are similar to coin problems, where we're going to have two equations and two unknowns. So let's just get started and I'll try to explain these. I think these are pretty easy. I use these bucket things. I don't think the book uses the buckets, but I kind of like the buckets. So. Example 1, a druggist has one solution that's 10% iodine and another that's 50% of iodine. How much of each should the druggist use to get 100 milliliter of a mixture that's 20% iodine? Now some of you are probably figuring out how to do this without using any method that I'm going to use. That's fine, but these are going to get more complicated, so if you can understand what I'm doing, it'll be helpful for when they get more complicated. First thing that I do is I draw my buckets, and I don't know why I do it this way, but I find it very helpful. So we're going to have a 10% iodine solution mixed with a 50% iodine solution to get a 100 milliliters of a 20% iodine solution. So I'm going to call the first solution, the one that's 10% iodine, I'm just going to call that X. The book uses P sub N and D sub N for poured and dumped, but I don't know, that just sounds funny to me. So anyway, we have our first solution, we're going to add it to our second solution, and we're going to get 100 milliliters of our combined solution. Now in the buckets, I always put the quantity of our solution. I always put the milliliters or whatever in the buckets. I put the percentages underneath the buckets. So this is a 10% solution, so I put 0.1. I'm adding it to a 50% solution, and I want a 20% solution. So I always put my percentages underneath the buckets. So we're going to write two equations with our two unknowns. The first equation, you just go straight across the top. So we're going to have X milliliters plus Y milliliters equals 100 milliliters. The second equation is kind of like when we do coin problems and we have the value equation. This is going to be our value equation. So we're going to just multiply what's under the bucket with what's in the bucket, under the bucket with what's in it, etc., etc. So we're going to have 0.1, or we can just put, well, we'll just put 0.1 X plus 0.5Y equals 0.2 times 100. And the first thing you're going to do is get rid of your decimal point, because you don't like to deal with decimal points. So I'm going to move my decimal over. So I'm just going to actually erase them. Hold on a second. I always have a little bit of trouble doing my eraser on this thing. For some reason it does not like to change. Okay, so I'm going to move the decimal point over. I can't find my eraser either. Okay, forget that. Let's just go back and I'll rewrite it. So I have my first equation is just X plus Y equals 100, and I'm going to move my decimal point over. So I'm going to have X plus Y equals, and that would be 200. And I forgot the 5. 5Y equals 200. And then we can just use our elimination. I'll just multiply this second one or the first one, it doesn't matter which one, by a negative. And I probably didn't leave enough room to do this problem. So we're going to have X plus Y. Well, let me just distribute this through. So it's going to be, if I add negative X and a positive X, there's no X's. It'll be a negative 5Y, and a positive Y would be a negative 4Y. Negative 200 and a 100 would be a negative 100. Divide both sides by 4, we get Y equals 25 milliliters. we have to go and find our other amount. Well, if y is 25, we know that x has to be 75. So x equals 75 milliliters. Now the second problem, you can see if we have 10% iodine solution, that means there's 90% water. If it's a 50% iodine solution, you can do 50% water. So there's a second way to do this. We could have made these percentages, instead of being how much iodine, we could have done how much water. So we could have had 90% plus 50% plus 80%. So that's just another way to do it. And we're going to do the second problem using the percentage of water. You can do it either way and get the same result. So let's just give this a try. This one says a chemist has one solution that's 10% salt and 90% water. Another solution that's only 2% salt. How many milliliters of each should the chemist use to make 1,400 milliliters of a solution that's 6% salt? So first thing you should do, just like when you do the distance problems, you draw your picture. Now, if you can get by without drawing your picture at some point, that's fine. But yay, the pictures are kind of cool. So, one solution that's 10% salt, so I'm going to put that one X. Another solution that is 2% salt. How many milliliters of each of these should he add to make one that's 1,400 milliliters? So remember, this one is your milliliters, and then we're going to put our percentages below it. This time we're going to do percentage of water. So 10% salt, you could put 0.1, but we're going to do it percentage of water this time. You just have to be consistent the whole way across. So that's going to be 0.9. This one's 2% salt, so that means it's going to be 0.98% water. And the final one, they want it to be 6% salt, so it'd be 0.94% water. So remember, that's your percentage, written as a decimal, of course. Then you just do your two equations. So your first equation is what's in the bucket. So it's x plus y equals 1,400. The second equation is these two things multiplied together. So 0.9x plus 0.98y equals 0.94 times 1,400. And then you can get rid of your decimal points. So that would be, this time we're going to have to move this one over 2 places. So we're going to have to move everybody over 2 places for these two guys. So we're going to have 90x plus 98y, and I can move this over and multiply all in one step. If you have calculators to do that kind of thing. So we're going to get 1,000, if I multiply this times this, it's a smaller number, so it's going to be smaller. We're not multiplying by 1, we're multiplying something smaller than 1. So it's 1,316. And then you're just going to use elimination, or you could use substitution. I do believe your book uses substitution. So you can solve this one for x and put it in, and I'm not going to do all this problem, but that's the setup. So we're going to get y equals 700 milliliters, and x equals 700 milliliters. And that's your final solution. So I didn't have enough room to do this all out, but you could just take x equals 1,400 minus y, and then take this and substitute it in for this x right there, and then it would be all in terms of y. So hopefully that's not too difficult. I think these are pretty simple if you understood coin problems. So you put the milliliters at the top, you put the percentage written as decimals at the bottom. Your first equation is just what's in the bucket. The second equation is the percentage multiplied times what's in the bucket. And then you just solve the system of 2 equations. So, class is tomorrow. I think I said 9:30. I'll put it in the email, the exact time. And I have have 4 lessons to do tomorrow. So get this one done today, and then we'll do the 4 tomorrow.